Welcome to Fall Asleep channel. Tonight, we explore gentle light, steady gravity, and slow orbital rhythm across a sun-centered region, a calm narrative with interesting facts. If you enjoy peaceful stories like this, you are warmly invited to subscribe and return whenever you need to slow down. Now allow yourself to get comfortable and enjoy quiet and pleasant rest. Let's begin. Light from a nearby star travels outward in steady waves, carrying energy formed deep inside through fusion where hydrogen gradually becomes helium, releasing heat and radiation that remain remarkably stable across long spans of time. This constant output shapes motion throughout the surrounding orbital neighborhood, from large rotating worlds to fine dust drifting along invisible paths. Gravity holds these paths in quiet alignment, allowing curves to remain smooth rather than abrupt. The central sphere contains more than 99% of all mass in this planetary family, which allows its pull to maintain predictable spacing and long-term stability. Surface temperature reaches several thousand degrees, while the outer visible layer remains cooler by comparison. Light leaving this surface requires just over 8 minutes to cross the distance to Earth, a steady interval that rarely changes. Subtle variations in brightness follow slow magnetic cycles. Faint surface patterns rotate calmly beneath glowing plasma layers, yet overall energy output remains balanced enough to support continuity across surrounding space. Streams of charged particles flow outward as stellar wind, shaping a wide magnetic region that gently deflects incoming interstellar material. This protective field stretches billions of miles, expanding and contracting slowly rather than sharply, closer inward. Rocky bodies follow compact paths shaped by higher temperatures during early formation. Dense material settled into solid surfaces, while lighter gases escaped or formed thin envelopes. The innermost world completes its circuit in less than 90 days, rotating slowly, creating long intervals of sunlight and shadow across its surface. Temperature variation follows this rhythm rather than abrupt change. The next rocky body carries a thick, reflective cloud layer, returning much of the incoming light back into space, maintaining surface pressure far greater than that found on Earth. Gentle circulation within these clouds distributes heat gradually, smoothing temperature differences across long spans. Farther outward, a blue world holds liquid water across much of its surface due to a narrow balance between distance, atmospheric composition, and rotational timing. A nearby natural satellite stabilizes axial tilt, influencing ocean movement through slow tidal motion, not through force, but through steady gravitational exchange. Beyond this region, a smaller red world preserves surface patterns shaped by ancient water flow. Mineral layers formed long ago remain visible in dry channels and sediment deposits. Thin atmosphere allows temperature to shift more widely between illuminated and shaded regions. Yet seasonal cycles remain slow and predictable. Between the inner worlds and the outer giants, a wide belt of rocky fragments occupies stable orbital space, containing millions of objects ranging from fine dust to mountain-sized bodies. These fragments preserve early formation material, drifting gently along shared paths without frequent collision. Larger gravitational fields beyond this belt capture thick envelopes of hydrogen and helium, forming massive spheres with layered cloud systems. Internal heat rises slowly from deep interiors, sustaining steady circulation rather than violent motion. One of these giants rotates in roughly 10 hours, flattening slightly at the poles, generating a powerful magnetic field that shapes charged particle flow into luminous auroral regions. Dozens of natural satellites follow this massive body, including one shaped by continuous volcanic activity driven by tidal flexing, and another that holds a deep subsurface ocean beneath a frozen surface. Energy exchange between gravity and internal friction maintains slow geological motion beneath thick ice layers. Farther outward, a ringed giant displays complex band patterns, an extensive ring system composed of ice and rock fragments arranged into countless narrow divisions. Light scatters softly across these layers, casting long shadows that drift gradually as orbital geometry shifts. Its largest moon contains lakes and rivers of liquid hydrocarbons beneath a dense atmosphere, while another icy companion reflects sunlight with remarkable brightness due to fresh frozen surfaces. Beyond these giants, two distant worlds rich in methane display blue-green hues, rotating on unusual axial tilts that generate extended seasonal cycles spanning many years. Winds sweep gently through upper cloud layers, while interior heat continues rising slowly from deep cores. Farther still, countless small icy objects form extended reservoirs of frozen material. Some follow long looping paths inward over centuries or longer, warming gradually, releasing gas and dust, forming luminous tails that always extend away from the light source due to particle flow and radiation pressure. Orbital motion remains governed by simple gravitational balance: faster movement closer inward, slower motion farther outward, creating predictable timing that supports long-term stability across billions of years. Slight resonances between orbital periods shape spacing within belts and rings, maintaining order without rigid alignment. Fine dust participates in slow inward drift influenced by radiation pressure and magnetic interaction, recycling material gently over extended timescales. Energy from the central star drives atmospheric circulation on many worlds, shaping cloud bands, temperature gradients, and wind patterns that redistribute heat without sharp transitions. Despite wide variation in size, composition, and distance, all bodies remain linked through shared gravity and continuous motion, suspended within a balanced rhythm that unfolds quietly, without acceleration, without interruption, as light continues traveling outward and particles move through invisible fields. Motion carries forward into deeper regions where orbits stretch wider and slower. Time itself expands into longer cycles, allowing alignment to persist as paths curve gently onward, never closing into a final point, remaining open, flowing, and steady. Farther from the brighter inner region, spacing between paths increases, motion slows, yet the same gravitational balance continues guiding every curve without interruption. Some icy bodies follow wide circular routes that take decades to complete. Others trace stretched ellipses that may require centuries or even thousands of years to return near the light source. These distant objects preserve frozen water, carbon dioxide, methane, and nitrogen, remaining largely unchanged since early formation. Temperature here drops to only a few dozen degrees above absolute zero, slowing molecular motion, keeping surface chemistry quiet across long intervals. Weak sunlight still arrives, scattered and softened, faintly illuminating reflective ice and drifting dust. Magnetic influence fades gradually with distance, allowing cosmic particles from beyond to blend gently near the outer boundary of the heliosphere. This boundary shifts slowly with magnetic cycles, expanding and contracting like a long breath across billions of miles. Beyond this region, interstellar space continues without sharp division, background radiation and sparse gas flowing steadily through open volume. Closer inward again, rings surrounding giant worlds remain shaped by countless small collisions, and gravitational shepherding from nearby moons, forming narrow gaps, wave patterns, and layered structures that evolve slowly over time. Individual ring particles range from fine grains to house-sized ice fragments, reflecting light and casting faint moving shadows. Orbital resonances between moons preserve stable spacing, preventing close approaches while maintaining long rhythm. Many satellites display locked rotation, showing the same face toward their parent world due to gradual tidal synchronization. Internal heating on several moons arises from slow stretching along elliptical paths, maintaining subsurface liquid layers beneath thick ice shells. Thin atmospheres appear temporarily on smaller bodies as surface material gently escapes under weak gravity, changing subtly with seasonal temperature cycles. Dust fragments collide and disperse slowly, contributing to faint zodiacal glow visible from inner regions when light scatters along the orbital plane. Gravity slightly bends passing light, a subtle effect measured to refine mass estimates and orbital models. Rotational tilt varies widely across worlds, from nearly upright alignment to extreme angles, creating long seasonal illumination cycles. Day length differs dramatically, from rapid spins lasting only hours to slow rotations stretching across many Earth days. Atmospheric pressure spans enormous range, from near vacuum to dense cloud layers capable of sustaining complex circulation bands. Chemical composition includes hydrogen, helium, nitrogen, carbon dioxide, methane, ammonia, and trace noble gases, shaping thermal behavior and cloud formation differently on each world. Surface gravity varies with mass and radius, influencing mountain height, dust settling, and gas retention over time. Impact craters preserve early history on airless surfaces, while active regions recycle terrain slowly through volcanic or tectonic motion. Reflective ice caps grow and shrink with orbital timing, altering brightness and local temperature balance. Subtle axial wobble shifts incoming light distribution gradually, influencing long-term climate patterns without destabilizing motion. Radio emissions from magnetic fields reveal interior structure and rotation timing. Tiny, irregular satellites follow tilted or backward paths captured through ancient gravitational interaction. Many small objects cluster near stable balance points where gravitational forces cancel naturally, forming long-lived populations sharing similar orbits. Cometary nuclei contain porous mixtures of ice and dust, releasing gas when warmed, forming expanding halos and curved tails shaped by particle flow and radiation pressure. Meteor streams arise when these travelers leave debris trails intersecting inner paths, producing periodic light displays as fragments encounter atmosphere. Gradual orbital migration occurs when angular momentum exchanges slowly reshape spacing across extreme timescales. Reflected light measurements reveal surface composition and temperature without direct contact. Gravitational interactions influence slow precession cycles, altering seasonal patterns over tens of thousands of years. Despite immense diversity, energy input remains dominated by steady radiation from the central star, maintaining long-term thermal balance across the entire region. The gravitational field preserves coherence through simple physical rules rather than constant adjustment, allowing complexity to unfold while stability remains intact. As distant paths sweep slowly and inner worlds maintain quicker rhythm, alignment continues carrying motion forward into widening arcs where time stretches gently and continuity remains unbroken, flowing onward without boundary or closure. As motion continues spreading across wider distance, subtle differences in mass and spacing keep shaping how each path responds to shared gravity, creating layered timing rather than uniform rhythm. Closer routes complete their cycles quickly, while farther arcs stretch across many decades, allowing temperature patterns, illumination angles, and surface chemistry to unfold at different speeds without conflict. Reflective surfaces return part of incoming light back into space, moderating heat buildup, while darker regions absorb and release energy slowly, smoothing thermal change across long intervals. Thin atmospheres exchange particles gently with surrounding space, allowing gradual loss and renewal, while thicker envelopes recycle heat internally through slow rising and sinking currents. Cloud layers form where temperature and pressure meet balanced conditions, drifting steadily rather than breaking into sharp boundaries. Rotation speed shapes how these layers stretch or curve. Faster spins creating narrow bands, slower spins allowing broader circulation cells. Magnetic fields generated by rotating conductive interiors guide charged particles into curved paths, forming radiation belts and glowing polar regions that evolve gradually. These fields also reduce direct particle erosion of upper atmospheres, preserving long-term gas stability. Internal heat persists in several large bodies due to slow radioactive decay and residual formation energy, supporting gentle convection beneath stable surfaces. Some rocky landscapes preserve smooth plains formed by ancient lava flows, remaining largely unchanged due to limited erosion. Tectonic movement varies widely, from near stillness to slow crustal shifting that reshapes terrain across immense time spans. Micro-impacts continuously refresh surface layers, distributing fine material and altering reflectivity in subtle ways. Polar regions collect volatile frost that migrates seasonally, recording orbital timing through layered deposits that accumulate gradually. Axial tilt determines how evenly light spreads across yearly cycles, shaping whether poles remain shaded reservoirs or receive extended illumination. Orbital eccentricity introduces mild variation in received energy without disturbing alignment. Resonance interactions between neighboring paths maintain spacing and timing, preventing drift into overlapping trajectories. Slight gravitational exchanges redistribute angular momentum gently, supporting equilibrium rather than instability. Moons contribute additional regulation by stabilizing rotation, influencing tides, and redistributing mechanical energy through slow frictional exchange. Ring systems continue reshaping through countless micro-collisions and gravitational sculpting, preserving thin layered structure and fine gaps. Light reflected from ring particles varies with viewing angle, creating soft brightness modulation over long cycles. Small, irregular satellites preserve tilted or reversed paths captured long ago. Dust migrates inward under weak forces, replenishing inner regions with fine particles that scatter light. Observation techniques measure brightness, motion, spectrum, and timing to infer composition and structure without direct sampling. Radio signals reveal interior conductivity and rotation behavior. Orbital timing confirms long-term predictability with high precision, despite immense diversity in size, composition, and distance. The governing forces remain simple and consistent, allowing countless environments to coexist within one coherent gravitational field. As light continues outward and motion remains steady across every scale, nearer paths maintain their quicker cadence. Farther arcs stretch into longer sweeps, carrying the same alignment forward through widening space where cycles overlap gently and continuity flows onward without interruption. Even across these widening distances, subtle interactions continue shaping balance without drawing attention to themselves. Tiny variations in orbital spacing influence how neighboring paths adjust over long spans, smoothing potential drift before it becomes noticeable. Mass distribution across large bodies shapes gravitational gradients that guide dust, ice, and smaller fragments into stable lanes rather than chaotic scattering. These gentle channels preserve spacing and timing across millions of revolutions, allowing motion to remain ordered without rigidity. Light arriving at different angles influences how surfaces store and release warmth, creating slow gradients that guide seasonal frost migration. Darker materials absorb energy and radiate it gradually, while reflective ice moderates heating and stabilizes local temperature. This quiet exchange smooths extremes and supports continuity rather than contrast. Thin atmospheres respond softly to illumination changes, expanding and contracting without turbulence, while dense cloud layers redistribute energy through wide looping circulation that remains layered and calm. Magnetic regions evolve gradually as internal rotation shifts field orientation slightly over long cycles, guiding charged particles into curved paths that trace invisible geometry rather than abrupt flow. These particle belts wax and fade gently as external pressure changes, preserving stable radiation environments rather than sharp exposure transitions. Internal layering within massive bodies separates dense cores from lighter outer shells, influencing heat transport and long-term rotation behavior without surface disruption. Surface materials respond slowly to thermal cycling, expanding and contracting in tiny increments that generate fine granular regolith rather than fracture. Electrostatic forces lift microscopic grains briefly in low gravity, allowing them to settle again and redistribute surface texture gradually. Porous ice and rock trap trace gases that migrate quietly through microchannels, releasing gently when temperature rises and sealing again as conditions stabilize. Weak seismic activity on certain bodies redistributes internal stress without visible surface change, maintaining structural balance rather than releasing energy suddenly. Tidal interaction between paired bodies transfers angular momentum slowly, adjusting rotation rate and orbital spacing in increments that remain imperceptible within short spans. Libration introduces small orientation variation, preventing prolonged static illumination and distributing surface exposure gently over time. Long-period illumination cycles shape frost layering and volatile movement across distant surfaces, producing soft brightness changes rather than sharp transitions. Spectral measurements reveal gradual chemical alteration driven by radiation and slow temperature fluctuation, preserving overall composition while allowing minor evolution. Isotopic ratios remain largely unchanged in colder regions, maintaining records of early formation environments over immense durations. Dust streams persist along shared orbital paths, linking otherwise distant zones through faint material exchange that remains evenly distributed rather than concentrated. Infrared emission traces thermal inertia across varied surfaces, revealing how different materials buffer energy and smooth temperature shifts. Gravitational field mapping refines understanding of internal density distribution, confirming layered structure without direct contact. Small deviations in orbital timing accumulate predictably, allowing long-term projection of alignment far into the future. Proportional response ensures that variation disperses gently rather than amplifying into instability. Motion remains continuous because each influence balances against surrounding forces, not through correction, but through alignment. And so the quiet relationship between distance, light, gravity, and motion continues unfolding. Nearer paths maintaining their quicker rhythm, farther arcs extending into longer sweeps, every fragment carried forward within the same steady field of influence. Where cycles overlap softly, change proceeds without urgency, and continuity remains open. flowing onward into the next gentle interval without boundary, without signal, without end. Within this ongoing flow, even the smallest variations contribute quietly to the larger pattern, reinforcing stability through countless gentle adjustments rather than visible shifts. Microscopic differences in surface texture influence how light scatters and how heat is retained, guiding slow redistribution of fine material across plains, slopes, and shadowed basins over long spans. These movements remain gradual enough that no single moment defines change. Instead, continuity emerges from repetition and balance. Porous layers within rock and ice regulate how gases migrate, allowing pressure to equalize slowly through narrow channels, preventing sudden release and preserving internal calm. Phase transitions inside layered ice occur quietly as temperature and pressure drift slightly, reshaping density and mechanical strength without surface expression. Internal circulation transports trace heat upward at measured pace, sustaining layered structure while outer regions remain stable and undisturbed. Gravity continues organizing matter across every scale, from guiding large orbits to shaping fine dust distribution along shared planes. Weak resonances maintain spacing across belts and clusters, preventing gradual crowding and preserving open geometry through long epochs. Angular momentum exchanges remain evenly distributed, adjusting spacing and rotation without favoring accumulation or loss. Light interacts continuously with surface chemistry, darkening exposed compounds slowly while fresh material brightens localized regions after minor impacts, creating subtle visual texture that evolves without abrupt contrast. Ultraviolet radiation alters upper atmospheric layers gently, forming thin protective hazes that absorb high-energy wavelengths while allowing visible light to pass through. Supporting chemical stability across extended intervals, thin gas envelopes expand and contract softly with temperature change, maintaining equilibrium without turbulence, while dense atmospheres sustain broad circulation loops that transport energy calmly between illuminated and shaded zones. Cloud particles grow and dissolve continuously, recycling moisture and trace compounds in slow cycles that resist depletion. Electromagnetic influence remains present even in diffuse regions, guiding charged particles along curved paths that reveal invisible field structure without producing disruption. Boundary zones shift gradually as particle pressure changes, expanding and contracting in smooth rhythms rather than sharp transitions. Background radiation provides steady baseline energy that moderates extremes and supports long-term chemical consistency. Impact frequency remains low in distant regions, allowing delicate surface features and layered deposits to persist for extended durations. When fragments disperse, they spread thinly rather than forming dense fields, contributing to gentle recycling rather than accumulation. Rotation continues shaping how surfaces experience light and shadow, smoothing thermal gradients and guiding slow regolith movement. Axial orientation drifts gradually through weak gravitational interaction, altering illumination geometry across thousands of cycles without destabilizing orbit. Every process remains linked through proportional response. Variation disperses through surrounding structure rather than concentrating, preserving coherence without rigidity. Motion continues because balance emerges naturally from timing, spacing, and continuous interaction, not through correction or intervention. As nearer paths sustain their quicker cadence and farther arcs unfold across longer intervals, the entire planetary environment remains connected through shared motion and quiet alignment. Distance stretches time without breaking continuity. Cycles blend gently into one another, and the steady progression carries forward into the next unfolding span where movement remains calm, open, and uninterrupted, flowing onward without boundary or final marker. Across this expanding field of motion, continuity remains the defining quality rather than change. Every rotation, every slow drift of dust, every faint exchange of energy contributes to a larger pattern that remains stable through proportional balance. Light arriving at shallow angles creates long gradients of illumination across curved surfaces, guiding temperature change gently rather than sharply. Materials respond by expanding and contracting in tiny increments, generating fine textures instead of fractures, and allowing landscapes to evolve through accumulation rather than disruption. Minute variations in surface reflectivity alter how warmth is stored and released, shaping slow thermal memory that smooths daily and seasonal fluctuation. Darker regions radiate energy gradually into surrounding space, while reflective ice moderates absorption and maintains cooler equilibrium. This interplay regulates surface chemistry and volatile migration without visible boundary lines. Thin gases continue exchanging particles with surrounding space, maintaining delicate equilibrium through slow loss and replenishment, while thicker envelopes preserve internal circulation loops that transport energy calmly from warmer zones toward cooler regions. Cloud layers rise and settle softly, condensing and dispersing in repeating cycles that resist instability, maintaining layered order across long spans. Magnetic alignment inside rotating interiors remains steady, guiding charged particles into smooth arcs that trace invisible geometry. Radiation belts form and evolve gradually, responding proportionally to changing particle flow without abrupt transitions. Deep interior heat migrates outward through layered material, sustaining slow convection that preserves structural integrity without surface disturbance. Gravitational interaction remains subtle yet persistent, shaping spacing between paths, regulating timing, and preventing gradual drift into irregular patterns. Resonance relationships continue reinforcing long-term order, allowing clusters of objects to share synchronized motion without crowding. Angular momentum exchange proceeds in tiny increments, maintaining balanced distribution rather than accumulation. Fine dust responds to weak forces with slow migration, contributing to faint background glow and gentle recycling of material. Electrostatic charging lifts microscopic grains briefly, allowing them to settle again and redistribute surface texture quietly. Porous structures within ice and rock regulate internal gas movement, supporting gradual pressure balance rather than sudden release. Seasonal illumination patterns stretch across long cycles, shaping frost deposition and migration in layered records that accumulate slowly. Isotopic composition remains largely preserved in colder regions, maintaining stable chemical memory across immense durations. Spectral signatures reveal subtle ongoing processing driven by radiation and thermal cycling, indicating slow evolution rather than transformation. Measurement of motion, brightness, and timing continues refining understanding of mass distribution and internal structure, confirming long-term predictability and stability across countless revolutions. Even as every component remains in motion, alignment persists through proportional response rather than rigid constraint, allowing variation to disperse naturally into surrounding balance. And so the quiet relationship between light, gravity, distance, and time continues unfolding, nearer paths maintaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change proceeding without urgency, continuity remaining open, and motion flowing onward into another calm span where alignment holds and the rhythm remains unbroken. Movement continues without emphasis, carried not by force but by proportion, each path responding gently to surrounding influence rather than asserting direction. Even the smallest shift in mass or spacing redistributes motion subtly across neighboring routes, smoothing variation before it becomes visible. This quiet feedback preserves spacing across long spans, allowing rhythm to remain even without rigidity. Light continues arriving in soft gradients, shaping temperature and surface behavior gradually. Materials respond by storing and releasing warmth at different rates depending on density, texture, and composition, creating slow thermal memory that buffers short fluctuation. Frost migrates gently along shadow boundaries, settling where illumination remains limited, lifting again when exposure returns, recording orbital timing in thin layered traces rather than abrupt change. Gas behavior remains calm across low-pressure environments, molecules drifting freely and exchanging slowly with surrounding space, while denser envelopes maintain broad circulation loops that distribute energy without turbulence. Condensation and evaporation proceed continuously, recycling trace compounds in steady cycles that preserve atmospheric stability. Cloud particles grow, dissolve, and reform without sharp boundaries, sustaining layered structure through repetition rather than control. Magnetic influence continues shaping charged particle motion, guiding flow into curved belts that wax and fade gently with changing particle pressure. Field orientation shifts slowly as internal rotation evolves, preserving long-term coherence rather than introducing variability. Internal heat migrates outward through layered material, sustaining quiet convection deep below surfaces that remain visually unchanged, maintaining structural equilibrium through gradual energy transfer. Gravitational alignment remains the underlying organizer, regulating timing and spacing across every scale. Resonance patterns continue reinforcing long-term order, preventing slow drift into irregular clustering. Angular momentum exchanges remain balanced, adjusting rotation and orbital geometry in increments too small to notice within short spans. Dust responds to weak forces with slow redistribution, contributing to faint background glow and gentle material recycling. Electrostatic charging lifts fine grains briefly, allowing them to settle again in smooth surface texture over long durations. Porous structures regulate internal gas migration, preventing pressure imbalance and supporting quiet stability. Illumination geometry shifts gradually through axial drift and orbital variation, altering seasonal exposure without destabilizing surface conditions. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral analysis reveals subtle molecular processing driven by radiation and thermal cycling, reflecting slow adaptation rather than transformation. Measurement of motion and light continues refining understanding of mass distribution and internal layering, confirming long-term predictability across countless revolutions. Even as every element remains in motion, coherence persists through proportional response rather than constraint. Variation disperses naturally into surrounding balance, and so the continuous relationship between distance, gravity, illumination, and time unfolds without interruption. Nearer paths sustaining their quicker cadence, farther arcs extending into longer sweeps, each fragment carried forward within the same steady field of influence, cycles overlapping softly, change unfolding without urgency, alignment remaining intact, motion flowing onward into another calm interval where continuity remains open, stable, and quietly sustained. As this steady progression continues, attention shifts naturally toward the subtle exchanges that rarely draw notice yet sustain long-term consistency. Minute thermal differences guide how surfaces release stored warmth into surrounding space, shaping gentle gradients rather than sharp contrasts. Materials expand and contract almost imperceptibly with each slow cycle of illumination, generating fine texture and gradual smoothing rather than fracture or disruption. This quiet physical response allows landscapes to mature through accumulation of tiny adjustments rather than visible transformation. Microscopic dust grains drift across low-gravity terrain, nudged by weak electrostatic forces and faint thermal currents, settling into shallow depressions and shadowed zones where motion slows further. Over long spans, these migrations alter reflectivity and heat retention just enough to influence local balance without creating distinct boundaries. Porous layers beneath the surface regulate internal gas movement, allowing pressure to equalize through narrow pathways that release gently and reseal as temperature stabilizes. Thin atmospheric layers remain loosely bound, exchanging particles slowly with surrounding space while preserving delicate pressure balance. Denser envelopes maintain broad circulation loops that move energy calmly from warmer regions toward cooler ones. Cloud structures grow, disperse, and reform continuously, recycling moisture and trace compounds in repeating cycles that resist instability and preserve layered order. Condensation occurs gradually rather than suddenly, allowing smooth transitions between phases without turbulence. Magnetic structure evolves with quiet consistency, guiding charged particles along curved trajectories that trace invisible geometry. Radiation belts shift subtly as particle flow changes, expanding and contracting without abrupt fluctuation. Deep interior heat continues migrating outward through layered material, sustaining slow convection that preserves structural equilibrium beneath surfaces that remain visually unchanged. Gravitational interaction maintains spacing and timing across every scale, regulating motion through proportional influence rather than rigid constraint. Resonance patterns reinforce long-term order, preventing gradual crowding and preserving open geometry through extended epochs. Angular momentum exchanges distribute adjustment evenly across neighboring paths, allowing spacing and rotation to evolve smoothly without amplification. Illumination geometry shifts gradually as axial orientation drifts and orbital shape varies slightly, altering seasonal exposure patterns without destabilizing thermal balance. Frost deposits migrate slowly along illumination boundaries, forming layered records that accumulate over long cycles. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense spans. Spectral analysis continues revealing subtle molecular processing driven by radiation exposure and slow thermal cycling, indicating steady adaptation rather than rapid change. Background energy from surrounding space provides a constant baseline influence, moderating extremes and supporting chemical stability across wide distance. Faint particle streams connect distant regions through gentle material exchange, maintaining continuity without accumulation. Infrared emission traces how different surfaces store and release heat, confirming gradual thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal structure and mass distribution, confirming predictability across countless revolutions. Even as every component remains in motion, coherence persists because variation disperses naturally into surrounding balance, rather than concentrating into instability. And so the relationship between distance, light, gravity, and time continues unfolding without interruption, nearer paths sustaining their quicker cadence, farther arcs extending into long, sweeping intervals. Each fragment carried forward within the same steady influence, cycles overlapping softly, change unfolding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and quietly sustained. Across this shared field of motion, continuity continues expressing itself through repetition rather than novelty. Every orbit retraces a familiar curve. Every rotation renews a quiet exchange between surface and light, reinforcing stability through steady rhythm rather than visible change. Heat absorbed during illumination releases slowly into surrounding space, smoothing contrast and guiding temperature toward gentle equilibrium. Materials respond with subtle expansion and contraction, shaping texture and fine-grained structure without fracture or displacement. Fine particles continue migrating in low-gravity environments, lifted briefly by electrostatic charge, settling again as balance returns, redistributing surface layers in thin, gradual waves rather than abrupt movement. Shadowed regions collect frost where illumination remains limited, while exposed slopes release volatiles slowly back into surrounding space. This steady migration records orbital timing in layered traces that accumulate over long intervals. Gas behavior remains calm and diffuse, molecules drifting freely through thin envelopes, exchanging gradually with surrounding space, while denser atmospheres maintain broad circulation loops that move energy quietly across latitude and altitude. Cloud formation follows slow condensation patterns, dissolving and reforming continuously without sharp boundaries, preserving layered structure through repetition rather than control. Magnetic alignment remains steady within rotating interiors, guiding charged particles into smooth, curved paths that trace invisible structure across surrounding space. Radiation regions wax and fade gently as particle pressure shifts, remaining proportional rather than abrupt. Interior warmth migrates outward through layered material, sustaining slow convection and preserving internal balance beneath surfaces that remain visually unchanged. Gravitational influence continues regulating spacing and timing across every scale. Small perturbations distribute naturally through surrounding paths, preventing amplification and preserving long-term coherence. Resonance relationships maintain predictable alignment, preventing gradual drift into irregular clustering. Angular momentum exchanges remain evenly balanced, adjusting rotation and spacing in increments too small to perceive within short spans. Illumination geometry shifts slowly through axial drift and mild orbital variation, altering seasonal exposure without disrupting thermal balance. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral signatures reveal subtle molecular processing driven by radiation and slow temperature change, reflecting gradual adaptation rather than transformation. Background radiation continues providing steady baseline energy, moderating extremes and supporting chemical stability across wide distance. Faint particle streams link distant zones through gentle material exchange, maintaining continuity without accumulation. Infrared emission traces thermal inertia across varied surfaces, confirming smooth energy storage and release rather than sharp fluctuation. Measurement of motion and light refines understanding of mass distribution and internal layering, confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than concentrating into instability, and so the quiet relationship between distance, gravity, illumination, and time continues unfolding, nearer paths sustaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change unfolding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and quietly sustained. As this calm progression carries forward, the sense of scale remains wide yet gentle, not defined by distance alone, but by the steady way timing stretches and compresses across different paths. Nearer routes complete their cycles quickly, renewing familiar patterns of light and shadow, while farther arcs unfold slowly, allowing surfaces to remain nearly unchanged for long spans before subtle variation appears. This layered timing allows many environments to coexist within one gravitational field without interference, each responding according to its own rhythm while remaining aligned with the whole. Thermal behavior continues shaping quiet balance. Materials with higher density store warmth longer, releasing it gradually into surrounding space, while lighter surfaces cool more quickly after illumination fades. This difference smooths temperature transitions rather than exaggerating them, guiding slow redistribution of frost, dust, and surface gases along gentle gradients. Shadowed basins preserve colder conditions, allowing volatile layers to remain stable across extended intervals. Exposed slopes warm and release material slowly, creating faint migration patterns that repeat predictably over many cycles. Thin gas layers maintain delicate equilibrium, molecules drifting freely and dispersing gradually into surrounding space, while thicker envelopes retain heat and transport it through broad circulation loops that remain layered and steady. Pressure changes occur slowly, allowing cloud structures to evolve without turbulence. Particles condense, merge, and dissolve continuously, recycling trace compounds in quiet cycles that sustain atmospheric stability. Magnetic influence remains present as a subtle organizing force, guiding charged particles into curved paths that reveal invisible geometry rather than visible structure. Particle regions expand and contract smoothly with changing pressure, never shifting abruptly. Interior heat continues migrating outward through layered material, sustaining slow convection that maintains internal equilibrium beneath surfaces that appear still. Gravitational interaction continues regulating spacing and timing, distributing influence proportionally rather than concentrating it. Small deviations settle naturally into surrounding motion, preserving long-term coherence without rigid constraint. Resonance relationships reinforce alignment across shared paths, preventing gradual drift and preserving open spacing through extended epochs. Angular momentum exchange proceeds evenly, adjusting rotation and orbital geometry in increments too small to notice within short spans. Illumination geometry continues shifting gradually as axial orientation drifts and orbital shape varies slightly, altering seasonal exposure without disrupting overall balance. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral signatures reveal subtle molecular processing driven by radiation exposure and slow thermal cycling, indicating steady adaptation rather than transformation. Background energy from surrounding space provides a constant baseline influence, moderating extremes and supporting chemical stability across wide distance. Faint material streams link distant regions through gentle exchange, maintaining continuity without accumulation. Infrared emission traces how surfaces store and release heat, confirming smooth thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal structure and mass distribution. confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than amplifying into instability. And so the relationship between light, distance, gravity, and time continues unfolding quietly. Nearer paths maintaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change proceeding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and gently sustained. Movement remains steady and unforced, carried by proportion rather than momentum alone, each path responding gently to surrounding influence rather than asserting direction. Even the smallest redistribution of mass or spacing alters nearby motion slightly, allowing balance to restore itself before any visible drift develops. This quiet feedback maintains spacing across immense spans, preserving rhythm without rigidity. Light continues arriving as a soft gradient rather than a sharp beam, shaping surface temperature gradually. Materials absorb and release energy at different rates depending on texture and composition, creating slow thermal memory that buffers rapid change. Frost boundaries migrate gently across shadowed terrain, advancing and retreating in narrow bands that trace orbital timing rather than dramatic shifts. Dust settles into shallow depressions where motion slows, forming smooth layers that alter reflectivity just enough to influence local balance without creating contrast. Gas behavior remains diffuse and calm, molecules drifting freely in thin envelopes, exchanging slowly with surrounding space, while thicker layers sustain broad circulation that transports heat quietly across latitude and altitude. Pressure gradients remain shallow, preventing turbulence and supporting long-term stability. Condensation and evaporation proceed continuously, recycling trace compounds in steady loops that preserve layered structure rather than exhausting resources. Magnetic structure evolves slowly within rotating interiors, guiding charged particles into curved paths that trace invisible geometry through surrounding space. Particle belts expand and contract gently as external pressure varies, maintaining proportional response rather than abrupt change. Internal heat migrates outward through layered material, sustaining quiet convection beneath surfaces that remain visually unchanged, preserving internal equilibrium through gradual energy transfer. Gravitational influence continues organizing motion across every scale, distributing variation evenly rather than allowing accumulation. Resonance relationships maintain predictable timing between neighboring paths, preventing gradual drift into irregular spacing. Angular momentum exchange proceeds in minute increments, adjusting rotation and orbital geometry so slowly that continuity remains uninterrupted. Illumination geometry shifts gradually through axial drift and slight orbital variation, altering seasonal exposure patterns without destabilizing thermal balance. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral measurements reveal slow molecular processing driven by radiation and gentle thermal cycling, reflecting gradual adaptation rather than transformation. Background radiation provides a constant low-level energy presence, moderating extremes and supporting chemical stability across wide distance. Faint material streams connect distant regions through gentle exchange, maintaining continuity without concentration. Infrared emission traces how different surfaces store and release warmth, confirming smooth thermal response rather than sharp fluctuation. Measurement of motion and timing continues refining understanding of internal structure and mass distribution, confirming predictability across countless revolutions. Even as every component remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than amplifying into instability. And so the quiet relationship between light, distance, gravity, and time continues unfolding, nearer paths sustaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change unfolding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and gently sustained. Even as these rhythms repeat, the impression is not of sameness, but of continuous refinement, each cycle adding a thin layer of adjustment that quietly improves alignment rather than altering direction. Surfaces remember previous exposure through stored warmth and gradual cooling, allowing temperature patterns to evolve smoothly rather than abruptly. This thermal memory guides how frost advances and retreats along shallow gradients, leaving faint layered traces that reflect long timing rather than sudden movement. Fine particles continue drifting across low-gravity terrain, nudged by gentle electrostatic charge and weak thermal currents, settling into shadowed pockets where motion slows further. Over extended spans, these migrations subtly reshape surface texture and reflectivity, influencing how light is absorbed and released without visible contrast. Porous material beneath the surface regulates gas migration, allowing pressure to equalize slowly through narrow pathways, releasing gently and sealing again as temperature stabilizes, preserving internal calm rather than producing visible change. Thin atmospheric layers remain loosely bound, exchanging molecules gradually with surrounding space, while denser envelopes maintain broad circulation loops that distribute energy steadily across altitude and latitude. Cloud structures form and dissolve continuously, condensing and dispersing without turbulence, sustaining layered order through repetition rather than control. Trace compounds recycle through slow chemical pathways driven by light exposure and gentle thermal variation, maintaining long-term consistency rather than accumulation. Magnetic organization continues shaping particle motion invisibly, guiding charged material into smooth arcs that reveal field geometry through movement rather than form. Radiation regions wax and fade gently as external particle pressure shifts, remaining proportional and stable. Interior warmth migrates outward through layered material, sustaining slow convection that preserves structural equilibrium beneath surfaces that remain visually unchanged. Gravitational interaction remains the primary organizer of spacing and timing, distributing influence evenly across neighboring paths, preventing amplification of small deviations. Resonance patterns reinforce predictable alignment, maintaining open geometry across countless cycles. Angular momentum exchange proceeds in increments so small that continuity remains uninterrupted, allowing gradual evolution without visible transition. Illumination geometry continues drifting slowly as axial orientation and orbital shape vary slightly, altering seasonal exposure patterns without destabilizing surface balance. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral observation reveals subtle molecular processing driven by radiation and slow thermal cycling, reflecting gentle adaptation rather than transformation. Background energy from surrounding space provides steady baseline influence, moderating extremes and supporting chemical stability across wide distance. Faint material streams connect distant regions through gentle exchange, preserving continuity without concentration. Infrared emission traces how different materials store and release warmth, confirming gradual thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal layering and mass distribution, confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than concentrating into instability. And so the relationship between light, gravity, distance, and time continues unfolding quietly, nearer paths sustaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change proceeding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and gently sustained. Beyond these repeating rhythms, subtle layering continues accumulating meaning through persistence rather than contrast. Each gradual exchange of energy, each minor redistribution of material, strengthens overall coherence without drawing attention to itself. Surfaces respond quietly to long exposure cycles, adjusting reflectivity and texture in thin increments that smooth transition rather than emphasize difference. This slow refinement supports stable temperature behavior and steady chemical balance across extended spans. Microscopic fractures close gently as materials relax under low stress, redistributing internal tension rather than releasing it suddenly. Granular layers settle into shallow contours shaped by gravity and weak electrostatic attraction, forming soft gradients instead of sharp ridges. Porous internal structures allow trace gases to migrate gradually toward equilibrium, preventing localized pressure buildup and sustaining long-term internal calm. Gas circulation remains organized by gentle pressure gradients, allowing molecules to drift rather than surge, preserving layered stability in thicker envelopes and diffuse balance in thinner ones. Condensation follows slow cooling patterns, producing clouds that expand and dissolve gradually without turbulence, maintaining continuity in atmospheric structure rather than abrupt transformation. Magnetic geometry evolves slowly with internal rotation, guiding particle flow into consistent curved trajectories that remain proportional to external influence. These regions adapt smoothly to changing particle density, expanding or relaxing without sudden transition. Internal heat continues migrating outward through layered material, supporting quiet convection that preserves structural alignment beneath surfaces that remain visually unchanged. Gravitational balance remains evenly distributed across spacing and timing, allowing each orbit to remain predictable while permitting slow long-term evolution. Resonance patterns continue regulating alignment across shared paths, preventing clustering and preserving open geometry. Angular momentum exchange proceeds evenly, maintaining proportional response rather than directional drift. Illumination patterns shift gradually as orientation drifts and distance varies slightly, altering exposure without destabilizing thermal balance. Isotopic composition remains largely preserved in colder zones, maintaining chemical continuity across immense durations. Spectral measurements reveal subtle molecular adjustment driven by steady radiation and slow thermal cycling, indicating refinement rather than transformation. Background radiation maintains a steady baseline influence, smoothing extremes and supporting chemical stability across wide distance. Faint streams of fine material continue linking distant regions through gentle exchange, maintaining continuity without accumulation. Infrared emission traces gradual heat retention and release across varied surfaces, confirming smooth thermal response rather than fluctuation. Precision measurement continues refining understanding of mass distribution and internal layering, reinforcing confidence in long-term predictability across countless revolutions. Even as motion never ceases, coherence persists because every variation disperses naturally into surrounding balance rather than concentrating into instability. And so the steady relationship between distance, light, gravity, and time continues unfolding without emphasis. Nearer paths maintaining familiar cadence, farther arcs stretching into wide intervals, every fragment carried forward within the same calm influence, cycles blending softly into one another, change proceeding quietly, alignment remaining intact, motion extending onward into another open span where continuity remains present, sustained, and gently unfolding without boundary or signal. Through all of this quiet continuity, what persists most clearly is the gentle cooperation between timing and distance, each orbit keeping its own pace while remaining synchronized with surrounding motion. Faster paths renewing familiar patterns of illumination, slower arcs stretching those same patterns across wider spans, allowing surfaces, atmospheres, and internal layers to respond gradually rather than abruptly. This layered rhythm prevents sharp transitions and supports steady adaptation rather than sudden change. Thermal exchange continues shaping balance without drawing attention. Denser materials retain warmth longer, releasing it slowly into surrounding space, while lighter surfaces cool more quickly after illumination fades. This difference creates smooth gradients that guide frost migration and dust settling along shallow slopes rather than sharp boundaries. Shadowed regions preserve colder conditions, allowing volatile layers to remain stable across extended cycles. Exposed regions release material slowly, contributing to faint redistribution patterns that repeat predictably. Gas behavior remains calm and diffuse, molecules drifting freely through thin envelopes, exchanging gradually with surrounding space, while thicker layers maintain broad circulation loops that transport energy quietly across altitude and latitude. Pressure variation remains shallow, supporting layered structure and preventing turbulence. Condensation and evaporation proceed continuously, recycling trace compounds in slow loops that preserve atmospheric stability and resist depletion. Magnetic influence continues shaping particle motion invisibly, guiding charged material into curved paths that trace invisible geometry. Particle regions expand and contract smoothly with changing pressure rather than shifting abruptly. Internal heat migrates outward through layered material, sustaining quiet convection that preserves internal equilibrium beneath surfaces that appear unchanged. Gravitational interaction remains the underlying organizer of spacing and timing, distributing influence proportionally rather than concentrating it. Small deviations settle naturally into surrounding motion. Resonance relationships reinforce predictable alignment across shared paths, preventing gradual drift into irregular clustering. Angular momentum exchange proceeds in minute increments, allowing spacing and rotation to evolve slowly without disrupting continuity. Illumination geometry continues shifting gently as axial orientation drifts and orbital shape varies slightly, altering seasonal exposure without destabilizing surface balance. Isotopic composition remains largely preserved in colder regions, maintaining chemical memory across immense durations. Spectral observation reveals subtle molecular processing driven by radiation exposure and slow thermal cycling, reflecting gradual adaptation rather than transformation. Background energy from surrounding space provides a steady baseline influence, moderating extremes and supporting chemical stability across wide distance. Faint material streams connect distant regions through gentle exchange, maintaining continuity without accumulation. Infrared emission traces how surfaces store and release warmth, confirming smooth thermal response rather than sharp fluctuation. Measurement of motion, brightness, and timing continues refining understanding of internal structure and mass distribution, confirming predictability across countless revolutions. Even as every element remains in motion, coherence persists because variation disperses naturally into surrounding balance rather than amplifying into instability. And so the quiet relationship between light, distance, gravity, and time continues unfolding, nearer paths sustaining their quicker cadence, farther arcs extending into long, sweeping intervals, each fragment carried forward within the same steady influence, cycles overlapping softly, change proceeding without urgency, alignment remaining intact, motion flowing onward into another calm span where continuity remains open, stable, and gently sustained. As this wide field of motion continues extending without interruption, what remains constant is not any single object or pathway, but the quiet persistence of balance itself. Light keeps traveling outward in steady waves, shaping temperature, chemistry, and surface behavior wherever it arrives. Gravity maintains spacing and rhythm without force or correction, allowing paths to remain smooth and predictable across immense spans. Rotation turns surfaces through alternating illumination and shadow, guiding gradual warming and cooling that smooths daily and seasonal transitions into gentle cycles. Atmospheres adjust through layered circulation, redistributing energy and trace compounds calmly rather than abruptly. Magnetic fields curve invisible particle streams into structured regions that evolve slowly and proportionally. Ice migrates along shadow boundaries in thin layered deposits that record orbital timing across long intervals. Dust lifts, settles, and redistributes quietly in low-gravity environments, altering texture and reflectivity through accumulation rather than erosion. Internal warmth moves outward through layered material at measured pace, sustaining gentle convection beneath surfaces that remain visually unchanged. Spacing and timing continue adjusting through minute exchanges of momentum, maintaining long-term geometry without rigid locking. Resonance relationships preserve openness and prevent gradual crowding. Distant reservoirs of frozen material remain largely unchanged, conserving early composition while releasing occasional travelers along extended loops shaped by gravitational balance. Faint material streams link distant regions through gentle exchange, adding continuity across wide space. Background radiation provides a constant low-level energy presence that smooths extremes and supports chemical stability. Observation continues refining understanding of motion and structure through careful measurement of light and timing, revealing slow evolution rather than sudden change. Every micro-interaction contributes proportionally to the larger pattern, dispersing variation rather than concentrating it. Coherence emerges naturally from alignment and continuous motion rather than control. Nearer paths maintain their quicker cycles. Farther arcs extend into long, sweeping intervals. Distance stretches time without breaking continuity. Patterns overlap softly, one interval blending into the next without boundary or signal. Movement continues without urgency and without conclusion. Steady, open, aligned, flowing onward into another calm span of unfolding continuity that remains present, persistent, and quietly sustained across the vast shared field of motion.